We have balanced some chemical equations before. Let's try to balance some more. In some cases, we have a chemical equation which is a result of two or more equations. For example, this chemical equation is actually occurring when these two reactions take place. That is, first hydrogen peroxide decomposes to give water plus nascent oxygen. That species, we know oxygen exists as a gas, as O2 molecule. So whenever there is only one atom of oxygen, it is known as nascent oxygen. And this is a very unstable species. So then this H2O plus O reacts with potassium iodide to form KOH plus iodine. So this chemical equation is a result of these two reactions. So to get the final balanced equation, what we do is we try to balance each of the partial equation. So let's take the first equation. We have H2O2 gives water plus oxygen, that is O. If we count the number of atoms, we have 2 atoms of hydrogen on the reactant side, 2 atoms of hydrogen on the product side. We have 2 atoms of oxygen on the reactant side and 1 plus 1, 2 atoms of oxygen on the product side. So the first partial equation is already balanced. Now let's look at the second equation. We have Ki reacts with water plus nascent oxygen to form KOH plus I2. Let's write the different atoms present here. Potassium, iodine, hydrogen and oxygen. Now let's count the number of atoms. So on the reactant side, we have 1 potassium atom, 1 iodine atom, hydrogen we have 2 atoms, and oxygen 1 plus 1, 2. On the product side, we have 1 potassium atom, 2 iodine atoms, 1 hydrogen atom, and we have 1 oxygen atom. So now let's rewrite the equation. So we see that on the reactant side, we have 1 potassium atom and the product side we have 1. So potassium atoms are balanced. Iodine, we have 1 atom on the reactant side and 2 atoms on the product side. Should we balance iodine now? Well, if you remember the first trick, we have said that the species which is present alone, we always balance it in the end. So let's leave iodine for the end. Let's move over to hydrogen. We have 2 atoms on the reactant side and 1 atom on the product side. So to balance hydrogen, we have to take 2 molecules of KOH. Now we get 2 atoms of potassium, 2 atoms of iodine, 2 atoms of hydrogen and 2 atoms of oxygen. And on the reactant side, we have not made any change. So this remains the same. Now we see that the potassium atoms are also not balanced now. So by changing this number, potassium is not balanced. So let's balance potassium. We have to make this number 2. How can we do that? We can do that by taking 2 molecules of Ki. So when we take 2 molecules of Ki on the reactant side, now we get 2 atoms of potassium, we get 2 atoms of iodine, 2 atoms of hydrogen and 2 atoms of oxygen. On the product side, we have not made any change. So this remains the same. So we see that now potassium atoms balanced, iodine atoms are balanced, hydrogen atoms are balanced, and oxygen atoms are balanced. So this is a second partial chemical equation which is now balanced. Now we'll write the 2 partial equations. So this reaction is the result of these 2 partial equations, and we write the 2 partial equations in the balanced form. So the first partial equation was already balanced, and this is the second balanced partial equation. So let's add them up. So if we add them up, we get 2 molecules of Ki, we get 1 molecule of H2O2, we get 1 molecule of water and 1 oxygen atom. On the product side, we get 2 KOH, we get 1 iodine molecule, we get 1 molecule of water and 1 atom of oxygen. Now, if you will see, you see that 1 molecule of water on the reactant side gives 1 molecule of water on the product side. This means there is no change in water. In effect, this means that water is not participating in the final equation. So, we can cancel H2O from both the sides. Similarly, we see 1 atom of oxygen on the reactant side and 1 atom of nascent oxygen on the product side. Since we see equal amounts on both the sides, so we can cancel oxygen atoms also from both the sides. So now our balanced equation becomes 2 molecules of Ki plus H2O2 gives 2 molecules of KOH plus 1 molecule of iodine. So this chemical equation, which was a result of these two partial equations, we balanced each of the partial equation, and this is the final balanced chemical equation. So now let's see if this is balanced. On the reactant side, we have 2 atoms of potassium. On the product side, we have 2 atoms of potassium. We have 2 atoms of iodine. We have 2 into 1, 2 atoms of iodine. We have 2 atoms of hydrogen. We have 2 into 1, 2 atoms of hydrogen. And we have 2 into 1, 2 atoms of oxygen and 2 atoms of oxygen. So this is our final balanced chemical equation. Let's take another example. We are given 2 partial chemical equations. These 2 combine to give a final chemical equation. Now we have to find out that final balanced chemical equation. How do we get that? We balance each of the partial equations and we add them up. Let's take them one by one. So this is our first partial equation. We have ozone, which is O3, gives oxygen molecule, which is O2, plus nascent oxygen. So if we count the number of atoms, we have 3 oxygen atoms on the reactant side and we have 3 oxygen atoms on the product side. So our first partial equation is already balanced. Let's look at our second partial equation now. We have PbS combines with O to give PbSO4. What are the different atoms present here? We have lead, sulfur and oxygen. Now let's count the number of atoms. We have 1 lead atom, 1 sulfur atom and 1 oxygen atom. On the product side, we have 1 lead atom, 1 sulfur atom and 4 into 1, 4 oxygen atoms. Let's write our equation now. So we see lead is already balanced, sulfur is also balanced, but oxygen on the reactant side we have 1 atom, on the product side we have 4 atoms. So now we have to balance oxygen. So we balance oxygen by taking 4 atoms of oxygen. So what we get now is, this remains the same, sulfur atoms remain the same, and we get 4 atoms of oxygen. On the product side we have not made any change. So this remains the same. So this is our second balanced partial equation. So in order to get the final equation, we need to add the 2 balanced partial equations. So this is our first balanced partial equation. This is our second balanced partial equation. Initially we had seen that the species which are present on both the reactant and the product side, we try to cancel them. Now we see this nascent oxygen is present on both the sides. It's on the reactant side as well as on the product side. So in order to cancel it, it should be equal in quantity. This side we have 4 atoms. This side we have only 1 atom. So how can we make this 4? We multiply the entire first equation by 4. So we get 4 ozone molecules, we get 4 oxygen molecules, and we get 4 atoms of oxygen. Now we can cancel this 4 atoms of oxygen with those 4 atoms of oxygen, and we get PbS combines with 4 molecules of ozone to give 1 molecule of PbSO4 and 4 molecules of oxygen. So now let's see if this is balanced. We have one atom of lead on this side, one on this side. We have one sulfur atom, one sulfur atom. We have 4 3s are 12 oxygen atoms, and we have 4 plus 8, 12 oxygen atoms. So this is the final balanced chemical equation obtained from these two partial chemical equations. Let's take another example. We are given two partial equations and we have to find out the final balanced chemical equation. Let's take each partial equation one at a time. So this is our first partial equation. Let's write the different atoms that we have. Potassium, manganese, oxygen, hydrogen, and sulfur. Let's count the number of atoms. Potassium 1, manganese 1, oxygen is 4 plus 4, 8, hydrogen is 2, and sulfur is 1. Moving over to the product side, we have 2 atoms of potassium, 1 atom of manganese, then we have 4 plus 4, 8, plus 1, 9, plus 1, 10 atoms of oxygen. Then we have 2 atoms of hydrogen and 1 plus 1, 2 atoms of sulfur. Let's rewrite our equation now. So we see 1 atom of potassium on the reactant side, 2 atoms on the product side. So we have to balance potassium. To make this 2, we multiply this by 2. So we take 2 molecules of KMnO4. Now we get 2 atoms of potassium, 2 atoms of manganese, 4 2s are 8, plus 4, 12 atoms of oxygen, hydrogen remains 2, and sulfur remains 1. On the product side, we have not made any change, so they remain as it is. Now we see that potassium is balanced, but manganese on the reactant side we have 2 atoms, on the product side we have 1 atom. So now to balance manganese, we have to take 2 molecules of MnSO4. So when we make this 2, we get 2 atoms of potassium, 2 atoms of manganese, then we have 4 2s are 8, plus 4, 12, 13, 14. 14 atoms of oxygen, we have 2 atoms of hydrogen, and 2 plus 1, 3 atoms of sulfur. No change on the reactant side. Now we see potassium is balanced, manganese is balanced, but oxygen is not balanced. We have 12 atoms on the reactant side and 14 atoms on the product side. Should we balance oxygen now? No, we shouldn't, because we recall the trick which says that the species present alone should be balanced in the end. Let's move over to hydrogen. So we have 2 atoms on both the sides, and we have sulfur. We have 1 atom on the reactant side, 3 atoms on the product side. So let's balance sulfur. So we have to make this 3, and this can be done by taking 3 molecules of H2SO4. When we take 3 molecules, we get 2 potassium atoms, 2 manganese atoms, then we have 4 2s are 8 plus 12. So 12 plus 8, 20 oxygen atoms. Then we have 3 2s are 6 hydrogen atoms. And then we have 3 into 1, 3 sulfur atoms. We have not made any change on the product side, so these numbers remain the same. So now, what do we see? We see that potassium atoms are balanced, manganese atoms are balanced, hydrogen is not balanced. So should we balance hydrogen first or oxygen? We know we should balance hydrogen first. This is because oxygen is sitting alone, so we'll balance oxygen in the end. So on the reactant side, we have 6 atoms of hydrogen. On the product side, we have 2 atoms of hydrogen. So to make this 6, we have to take 3 molecules of water. So when we make this 3, we get 2 atoms of potassium, 2 atoms of manganese, then we have 4 2s are 8, plus 4 12, plus 3 15, plus 1 16 atoms of oxygen. Then we have hydrogen. So we have 3 2s are 6 atoms of hydrogen, and we have 2 plus 1, 3 atoms of sulfur. We have not made any change on the reactant side, so this remains the same. Now if you look at the equation, potassium balanced, manganese balanced, hydrogen balanced, and sulfur balanced. So now we are left with only oxygen. So to balance oxygen, we have to get this 20. So we see that we already have 4 plus 8 12 plus 3 15. So 15 atoms of oxygen, we need 5 more atoms. So we take 5 atoms of oxygen. So when we take this 5, we get 2 atoms of potassium, 2 atoms of manganese. We get 4 2s are 8 plus 4 12, 3 15 plus 5 20 atoms of oxygen, 6 atoms of hydrogen, and 3 atoms of sulfur. We have made no change on the reactant side, so these numbers remain the same. So if we now look at the equation, potassium is balanced, manganese balanced, oxygen balanced, hydrogen atoms balanced, and sulfur atoms balanced. Now let's look at the second partial equation. We had H2S plus oxygen atom react to give water plus sulfur. If you look at this equation, we have 2 atoms of hydrogen on the reactant side, 2 atoms of hydrogen on the product side. 1 sulfur atom, 1 oxygen atom on the reactant side, 1 sulfur atom, 1 oxygen atom on the product side. So our second partial equation is already balanced. Now let's add the 2 partial equations. We have balanced the first partial equation, and the second partial equation is already balanced. If we look at it, we see again oxygen atoms. This oxygen is present on both the sides, on the reactant side and on the product side. But again in this case, on the product side there are 5 atoms, and on the reactant side there is only 1. So in order to make this 5, we multiply the entire second equation by 5. So when we multiply this by 5, we get 5 molecules of H2S, 5 atoms of oxygen, 5 molecules of water, and 5 sulfur atoms. So now we have equal quantity of oxygen atoms on both the sides. So we can cancel this. So now on adding the 2 equations, we get 2 molecules of KMNO4, 3 molecules of H2SO4, 5 molecules of H2S. They give K2SO4 plus 2 molecules of MnSO4, 5 plus 3, 8 molecules of water, and 5 sulfur atoms. So this is the final balanced chemical equation. So by using 2 partial equations, we balance each of the partial equation, and in turn we get the final balanced chemical equation.